Okay, let me check. I think the screen is okay. So I think the screen is back online. That's great. Okay, then let's just do over. Okay. Sorry for the inconvenience. Okay, let's start with IPv6 routing. So I said that IPv6 routing contains 128-bit alphanumeric string. Okay, like this, like you can see. Okay, this basically uses the hexadecimal number system here. Okay, we can hash the write up to F because the hexadecimal is hash the can go to the F. Okay, so why we use IPv6? Because IPv4 is nowadays exhausting. Only 429 crores and something IPv4 addresses are there, but there are a lot more other websites who are trying to use the public IP address from IPv4. So this creates a huge void, or this causes the IPv4 address to exhaust. Okay, it's not exhausted completely, but it is about to. So that's why they introduced IPv6 concept here. So where we can get at least 340 billion addresses. Okay, so that is pretty much impossible to exhaust in upcoming 100 years. And also the funny thing is they say that if you give the IPv6 address to each and every object you can see, like table, chair, your bed, your bags, your laptop and everything, okay, still it is not going to exhaust in upcoming 100 years. So that is, the number is huge. It's 340 billion something like that. Okay, you can search it on Google, the total number of IPv6 addresses. Okay, so this is how a IPv6 address looks like, and this is how I have written this. This is how you can shorten the IPv6 address. One minute, yeah. This address can be written like this. Okay, pretty much shorter, right? We we don't have to write that much long. We can shorten the IPv6 address. And just remember, each and every part here, like these parts are called hex state in IPv6. Okay, each and every part contains 16 bits. So 8 parts, as you can see, 8 parts are there, or 8 hex states I can say, because because it is of 16 bit and it is using hexadecimal. So we can call it hex state. So 8 hex states, 16 bit, total 128 bit IPv6 addressing. Okay. So how we can shorten it? Just take a quick look about to it. Just one second. I think, yeah. So this is the IPv6 address. So what you can do, we can omit the left side 0, which has no value. So we can directly write DB8, and this contains the whole field is 0. So we can just write 0 here. Okay, instead of 4 zeros. As I said, left side 0 has no value, so left side has 3 zeros are in the left side, so we can directly write 1 here. Okay, and now if there are any consecutive fields of zeros, like suppose two fields are there, or like this three fields are there, like this, three consecutive zeros states. Okay, we can just put double colon for two fields, or for three fields, we don't care, we just put double colon there. Okay, like this. And we can write rest of the thing. 2800 is 2800, and 0001 can be written as 1 again. Okay, and here also we can see that there are three fields of consecutive zeros. Okay, still we wrote double colon here to depict that three consecutive fields of zeros. So how we can understand that this double colon means three consecutive fields of zeros, or two consecutive, or four consecutive fields of zeros? Pretty easy. When you see this IPv6 address, how many fields you can see? 2001, that's one field. DB8, that's second field. 0, third field. 1, fourth field, and this one, fifth field. So I can see 5 hex states are there already. So how many hex states I missed? 3. Because 8 hex states has to be there. So 5 hex states I can see, 3 hex states are missing. So that means this double colon depicts 3 hex states. That means 3 consecutive zeros of hex states. Okay. So now, so we can easily deduct that. Okay. Now let's come to IPv4 versus IPv6 quickly. Okay. So IPv4 versus IPv6 here. So this is a little bit comparison, like IPv4 has 32-bit address length because that has 4 octets of 8 bits, so that was 32-bit, and it uses 8 hexstates of 16 bits, that means 128-bit address length. And IPv4 supports manual and DHCP address configuration, and IPv6 supports auto and renumbering address configuration. Okay, there's a little bit difference when we go to the practical quickly, and we'll see to it. Okay, so now in IPv4, end-to-end connection integrity is unachievable, and in IPv6, end-to-end connection integrity is achievable. So that is pretty huge, because end-to-end connection integrity is achievable. That means it is pretty much secure and reliable. Okay, so it can generate 4.29 into 109 address space. So we have already talked about the address spaces, and that is for 429 crores something, you can calculate. And that's not 109, I think that's 10 to the power 9, sorry for the typo, and that's 3.4 into 10 to the power 38. That means it's 340 and decillion, or 340 billion, billion, yes, 4 times billion. So security feature is dependent on application. IPsec is inbuilt security feature in the IPv6 protocol. So there is an inbuilt security feature in IPv6 protocol. So obviously IPv6 is way more secure than IP4 addresses, and pretty liable to use. I mean reliable to use. Okay. So now if I go to IPv4 addresses here, yeah. Address representation of IPv4 in decimal, we represent it in decimal form, and in IPv6 we represent it in hexadecimal form. Okay, and there are lots of other differences, like in IPv4 packet flow identification is not available, it's available in the header. Checksum field is available, checksum field is not available. Okay, so there are lots of other differences. Okay, there are so many differences, but the main difference is um, and what makes IPv6, more reliable uh, in terms of, if you compare them with IPv4, that is the integrity, end-to-end integrity, and the security of IPsec, and the huge number of IP addresses we can get. So that is the main differences. Okay, that what makes IPv6 way much more ahead than IPv4. Okay, now let's get to types of IPv6. So we know that in IPv4 we see that unicast, broadcast, and everything is there. But in IPv6 there is unicast, anycast, and multicast. So what is unicast? Unicast addresses identify a single interface. Okay, only single interface. If I want to send some data, it will only go to a single interface. Okay. Now let's come to Anycast. Anycast addresses identify a set of interfaces in such a way that a packet sent to an Anycast address is delivered to a member of the set. Uh, or basically I can say, suppose I want to send a data. Suppose there are some servers, 4 servers connected to each other. Okay. Um, let's say like this. Okay, this is a Cisco packet tracer. This is where I'm going to show you the practical. Okay, this is the virtual simulation of Cisco environment. Okay, it says no available port. Okay, there is only one, and suppose I am just showing you that, suppose I am connecting this server. So now, if this server here tries to send a data, this server try to send the data to suppose this server, then what happen? Through Anycast, it cannot send to server 0 cannot send to server 3 via server 1 or server 2. In any case, the request will go to first this server 1, then server 1 create its own request and it will send to server 3, and again it will take the reply from server 3, okay, and then it will generate the new reply and it will take that reply to server 0. So that is how Anycast works, okay. Only the nearest computer will get the request first, I guess. Okay, so now multicast address. So before that, IPv6 has no broadcast addresses, multicast addresses to cover, just like that. Okay, so multicast addresses identify a group of interfaces in such a way that a packet sent to a multicast address is delivered to all of the interfaces in the group. So that is basically like broadcasting. Okay, that if I want to get something from server 3, I will broadcast it to or multicast it to server 1 and server 2 and everything. Okay, so this is the concept now of IPv6. And now let's come to the important part, which is variations of IPv6. Okay, so global unicast. First of all, IPv6 global addresses are similar to IPv4 public addresses. It's global or public, almost the same. As the name implies, they are routable on the internet. Currently, IANA has assigned only 2000 double colon slash 3 addresses to the global pool. So this is 2000 double colon addresses are assigned for this global unicast addresses. Now let's get to unique local. Unique local IPv6 addresses have the similar function as IPv4 private addresses. They are not allocated by an registry and are not meant to be routed outside their domain. So this kind of addresses like unique local addresses only can be routed into their own domain. Okay, not outside of their domain. So unique local IPv6 address begin with FD00 double colon something. Okay, great. And now finally it's link local address. These addresses have a prefix of FE80. They are mostly used for auto address configuration and neighbor discovery. If you get the time, we will try to see that how we can, you know, uh, create a link local address also. Okay, because this is for auto address configuration. So now that's up to it about IPv6. So let's just get to routing part directly. Okay, so this is what I'm going to use for this routing part. Okay, let's just clean this. Okay, great. So, what kind of routing we are going to do here? Okay, we'll basically start with the OSPF today. So let's create a routing table here. I'm just taking two different routers. So I'm going to put two different IP addresses here, and I'm going to show that how IPv6 routing can be done. So just let's get directly to it. Okay, I'm yeah adding the switch here. Okay, if I haven't used packet tracer yet, okay, this is how you can use it, and this is the actual virtual simulation of the real world Cisco packet tracer. Okay, here we can create a dummy network and we can practice. Okay, this is officially from the Cisco, and the download is free, obviously. Okay, so let's connect. I'm going to connect serial cables here for router to router connection. Okay, great. Oh, from serial cable to serial cable. Okay, and for the rest of it, it's going to be straight cables because router and switch are different devices, and switch and computer are also different devices. So it's going to be straight cable. Okay, so Just keep my, yeah, port string levels on. Yeah, now it's good. Okay, so what kind of IP addresses I'm going to use here? Let's say here I'm going to use a common IP address to, route the data correctly. So the IP address I'm going to use here, suppose it's 2001. What I have written earlier, that's I'm going to use DB8, maybe 1:1 and double colon slash 64. So this is the network address I'm going to use, IPv6 network address I'm going to use. Here I'm going to put, after that double colon I'm going to put 1, and after double colon here I'm going to put in this port 2. Okay, and I need some IP addresses here also. So 2001 DV8. I need different network address here, so I'm going to start with A001 or just 1:A001 double colon slash 64 here, and in here 2001 DB8 colon 1, so A002 double colon slash 64. So these are the IP addresses I'm going to use here. So without any delay, so let's start configuring the IP addresses. Okay, it looks too small. Let me check if I can make it a little bit larger. For the CLI mode, I can use this 16 maybe. Yeah, now I guess you can see it. Okay. So this is how we can enable the router. We'll go to the enable part here. Okay. So yeah. So how can we set IPv6 addresses here? So after enabling it, we need to get to the config mode. So config T, or you can write configure terminal. So let's get to the port, which is INT. The first port is known as S0by3 by 0. So S0/3/0 here. I have to mention the port number here. Okay. Or I can, yeah, just I need to enable something, IPv6 Unicast routing. So this is, I have to write IPv6 Unicast routing. Okay, this was incomplete, don't worry. So this is IPv6 Unicast routing I have to write to, you know, enable the unicast routing. Now I can get to INTS 0/3/0. Okay, so now I'm going to put the IP address here, which is IPv6 add, and the IP address I want to set is 2001 DB8 1:1 double colon 1. Okay, and slash 64. So this is the IP address I'm going to set here, and this contains a clock sign, as you can see. So I'm going to set a clock rate over here, which is clock rate, and maybe 72,000, and done, and no shut. Okay, so there is another interface which is G0/0. So I'm going to put int G0/0, and here I need to add IPv6 add. So the little bit change was, it's A001:1/64. No clock rate for this, and I'm going to put no shut over here. So as you can see, these all ports are turning green. Okay, and okay, this is it for the first router. Now let's get to the second router, and again, no, enable config T, and again IPv6 unicast routing. You have to enable it. Now I'm going to go to INT. So what is the port number here? It's 0/3/0 again, as you can see. So S0/3/0. and yeah, IPv6 add, it's 2001. The IP addresses I'm putting is TV8 1:1:2/64. No clock rate for this, so directly I can do no shut. So as you can see, the upper line is turning green also. Okay, so the next interface is here is int g0/0. So this is the 0/0, and again I'm to confirm int 0/0 IPv6, or I can just use it. Yeah, it was I think A002. So A002, and this has to be 1. Enter and no shut. So each and every port is going up now. So the computers, we need to set the IP addresses to the computers. That is very much important. So let's get to the computers, desktop, and IP configuration. So in IP address, so I'm going to write the IP address. What I'm going to set here, it's 2001. It's DB8. It's 1:A001 double colon 1. I have already set in the G0/0, and so I'm going to set here 2, and here I need to write the /64 part, and the default gateway is always like this. Copy and paste. Okay, the default gateway was :1. That's it. And again, let's get to this desktop. Here, put this. I'm going to put 3 here. I need to write 64 here and paste. This is 1 for this computer. Let's get to this computer and paste, which is 4. 64, paste, which is 1. Okay, so these computers are filled with IPv properly, and then here again we can do it, but little bit different, because I need A002 here. 64, paste 1 and A002 here. So I'm going to copy it to set it in the rest of the computers, and yeah, paste it. 3, 64, paste. So this is pretty quick, right? So we can also auto configure, but I prefer doing static IP just to show you. Okay, this is 4, 64, and this one. Okay, done. So IP addresses are also set, as you can see. If I hover it on it, yeah, I can see there is only one problem. I can see the gateway is not set. Let's write 64 here. Okay, it says invalid gateway addresses. Okay, no issues. Okay, so now when all the IP addresses are set and running, okay, now what we can do, but still the IPv6 will not, you cannot ping these networks, okay, successfully, because IPv6 won't allow until, or IPv4 even no won't allow until you do the routing here. Okay, so the routing is very much important out there. So let's implement, suppose the what I can say, OSPF. Let's start with OSPF routing. Okay, so I think everything is set properly here. Gateway, the IP addresses we have set, IPv6 address, and IPv6 addresses are set. Okay, also we can do one more thing. IPv6 configuration is automatic or static, and everything is running fine. Okay, and as you can see, link local IP address is already there. I don't have to set this. Okay, so I just leave it here. Okay, so let's start with the OSPF routing here. So I'm putting exit here. Okay, so I have to write IPv6 router um, router OSPF1. So it says that it could not pick the router ID, so I have to set the router ID manually. Okay, that's great. So set the router ID, suppose 1.1.1.1. Okay, this is how you have to set the router ID for this. Okay, so the router ID has been set. Okay, so now let's go get to each and every port out there. Just get this out from this router and int s0/3/0, and you have to IPv6 OSPF1 area 0, and let's get to int g0/0. Here also I have to write the same thing. Okay, this for the first router. Let's get to the second router here. Okay, exit IPv6 router OSPF1, and the router ID here will be the another ID. So 2.2.2.2 I'm putting here int as 0/3/0. So I can say that IPv6 OSPF1 area 0. Same goes for int g0/0. The same line I have to copy and paste. Okay, so now let's see if it can ping properly or not. So we cannot ping with this packet here. Okay, so yeah, let's get to the command prompt. Try to ping 2001 colon db8 colon 1 colon 8002 colon 2/64. Okay, so as you can see, it's pinging properly. So from this defined network, it is I'm trying to ping this network. The both networks are defined so that the routing is correctly configured. So let's get to the simulation to see it how it's happening. So the same I am going to put. Okay, now in the simulation, as you can see, the packet is going out from here. So it is going out to the get to the switch. It goes to the router. From this router, it will go to the switch and get to a destination, and then yeah, done. So this is how it is done every time I ping. Okay, so as you can see, OSPF version 3, ICMP version 6 is written. So the ICMP packet here is following the IPv6, that's why it's ICMP version 6 or OSPF version 3. And if I get to the here and yeah, in the simulation I have to run it like 4 times to complete the ping procedure. So it is showing different colors each time. Okay, so it says 0% loss, 100% receipt. Okay, so that means the IPv6 has been configured properly. So it is very easy to configure IPv6. So let's describe the command for you once again. So what I have to do, we have to put the IP addresses first in the correct ports. So suppose in 0 so first you have to enable the unicast routing. Then you have to go to the port in the interface. You have to add the IP address there, or set the clock rate or something, no shut. Okay, do the same thing for the next interface like G0/0, set the IP address, no shut, and done. And for both the routers, you do the same thing. Okay, and now after that, go to both routers and you have to write this IPv6 router OSPF. You can take any values you want, like 1, 2, 3, 4, any value you want to give. You have to give the router ID, so it has to be in this format, something dot something dot something dot something. So I have put 1.1.1.1. Now you have to exit and you can go to there and IPv6 OSPF1 area 0. This line you have to write each and everywhere. What we're doing here, we are doing this single area OSPF routing here. Okay, so this is how you can easily configure the IPv6 routing. Okay, so just the thing which you have to understand is how to create the IPv6 address, because it is very easy. As you can see, you can put any hexadecimal code just to practice. Okay. So now, as I told you that each and every computers got their link local addresses by default. So how this link local addresses works, how computer created this link local IPv6 addresses. So just let's get to uh, desktop here. Let's get to command here. Okay, so I'm going to check ipconfig slash all. Okay, so as you can see, the link local address is there. So how they created this link local address? So behind this link local address, the physical address is working here. So this is the physical address. So I'm going to copy the physical address and I'll show you how they create it. So yeah. So now I have copied the physical address or the MAC address of that computer here. So it's like 4.4.4 format. Okay, 4 digit dot 4 digit dot 4 digit. Okay, so I want to make it in pair, like 0002 4A 676440. So yeah, you have to break it in 2 to 2 formats. Now what you have to do, in the middle, as you can see, there are 6 pairs. So in the middle, after 3 pairs and before those 3 pairs, okay, you have to put something called FF and FE. So it will look like this. So the first step, you have to put FF FE in the middle. So then how it will look like? 0002 4A FF FE 676440. So now we can see, okay, this will look like this. Exactly in the between you have to put. Now the second part. Okay, this is quite easy. This is just you have to put FF and FE in the in between, and now in the second part you have to take the first pair, which is anything. It can be it can be either 00, it can be either anything. Okay, so it can be either 20 or something like that. So doesn't matter. Just look at it as decimal number and make it binary, 8-bit binary number. Just make it 8-bit binary. So for 0, the binary is always 0. So 8-bit binary will be 0000. So eight zeros I have to write. Okay. So this is it. Now what you have to do, this is the trickiest part. You have to take the 7th bit here. So this is the 7th bit in the 8-bit binary. You have to reverse it. Like if it is 0, if the 7th bit is 0, you have to make it 1. If the 7th bit is 1, you have to make it 0. Okay, you just have to reverse. So it's 0, so I'm making it 1 now. So when I make the binary 1, so that means the decimal has to change. So what is the value of 010? It's 2. So I can write 02. And I will replace this 02 in this list. So instead of 00, I'll write 02. Then again it is 02. It's 4A. It's FF. It's FE. Then 67. Then 64. And 40. Okay. And you have to, finally, you have to make it 4 digit dot 4 digit dot 4 digit again. It's like 0202 dot or colon. uh, it's 4A FF. Okay, then FE 67 and 6440. Okay, and to make it whole, as we know, the link local address always starts with FE80 double colon. So we just add in the fourth step FE880 double colon, and I will write the rest of it here. So this is how the address will look like. Now let's match it. So it's FE80202 4AFF FE67, right? So just match it. Match those both numbers. So it's similar. So they just remove the left side unnecessary zero, and it looks the same. So this is how the link local IP addresses are created from the MAC address of the device. So take the MAC address and divide it into pairs. Okay, just put FF and F in between. Take the first pair and make it 8-bit binary and change the 7-bit. If it is 0, make it 1. If it is 1, make it 0. And again write the whole as 4.4.4 format and add the F80 double colon at the prefix. That's it. And your link local address is here. Quite easy. Okay, so this is how IPv6 address works. Okay, so uh, hopefully you have understand that why we use IPv address and IPv6 address, as we call it, is the future now. Okay, because because of the IP4 address, because it is exhausting, and that's why it is pretty much important to understand that how IPv6 works, because in the future IPv6 will be used everywhere. Okay, so hope there is no doubt, because I have just explained a few things of IPv6. There are lots of other things. Okay, you have to learn. Okay, so you can subscribe our channel for another videos. Okay, so thank you for the session today, and sorry for the inconvenience we caused earlier. Okay, hope that doesn't create that much of problem. Okay, so thank you for that.